Hi. Today we're learning max and min word problems. Our learning goals are to learn to determine the maximum or minimum values of a quadratic function or parabola by putting it in vertex form. And we're also learning to solve word problems involving quadratic functions in vertex form. Really, these word problems will involve maxes or mins. They'll be max or min word problems. So to determine the maximum or minimum value of y for a parabola, so we learned that previously. If a is positive, so if the step number is positive, we know that our parabola looks like this. It opens upwards. It's going to have a minimum or a lowest point of k. And if a is negative, less than 0 means negative, it's going to be upside down, so it's going to have a highest point or a maximum also of k. So if your parabola is in vertex form, it's easy to tell what the maximum or minimum value is because it's the k value. Okay? And then if it's not in vertex form, that's what we want to do is put it in vertex form. So determine whether each parabola has a maximum or minimum value and determine what it is. Show your thinking. So as soon as we see the words maximum or minimum, you should be thinking completing the square, putting it into vertex form. So you need vertex form. So in order to put it in vertex form, the first thing you do is you common factor the a value, in this case negative 10, out of the first two terms. So the terms that contain x. So if you common factor negative 10 out of the terms containing x, negative 10x squared divided by negative 10 is x squared. Positive 20x divided by negative 10 is negative 2x. Close your bracket, minus 5. So again, if you were to expand here, you'd get negative 10x squared. Negative 10 times negative 2x is positive 20x. And then you'd still have your minus 5 because it's not being multiplied by the negative 10. So that's our first step. Our next step is to complete the square inside the brackets. So we do our x squared minus 2x, and then we take half of 2, which is 1, and square it. So half of 2 is 1. 1 squared is also 1. So we add 1. At the positive always completes our square. But in order to keep it balanced, we also have to subtract 1. So that really we're just adding 0. So this is adding 0, and you can always add 0. It doesn't affect one side of your equation to add 0. It keeps it balanced. But we've done that as a way that we can complete the square or change from standard form into vertex form. So if we look inside the brackets, the first three terms form the perfect square trinomial, or the x minus h part of your vertex, the x part of your vertex. So when you factor that, you're going to get, this is a perfect square trinomial, so you're going to get x, the sign from the middle is minus, square root of 1 is 1 squared. Now don't forget that squared, that's what makes it a parabola. But this negative 1 is left inside the bracket here. And in order to expand something and get it outside of a bracket, so I can combine it with the negative 5, it has to get multiplied by the number that's out front. So negative 1 times negative 10 is positive 10. And then I still have the minus 5. And then those two terms, plus 10 minus 5, give you positive 5, give you the k value. So now we're actually going to answer the question, does it have a maximum or a minimum? It has a maximum because of the negative sign on the a value, which means that it would be opening up like this, or opening downwards. So it has a maximum value of our k value, which is 5. Okay? The next one. So again, the first step is to common factor the a value, which in our case is a half, out of just the terms that contain x. So a half x squared divided by a half is x squared. And then you can use your calculator. -4 divided by, I'm going to put 0.5 instead of a half, gives you -8. Or you could do -4 divided by bracket 1 divided by 2 as a half, and you get -8. So -8x. Close your bracket because you're just factoring the a value out of the terms that contain x. And then you still have this -8. Don't forget about your c term. Okay? And again, if you were to distribute here, you'd get back what you started from. A half times x squared is a half x squared. A half times -8x is -4x. And then you still have your -8. So the next step is to complete the square inside the brackets. So x squared minus 8x plus, so to figure out what number, you take half of 8, which is 4. And if you didn't know that, you could do 8 divided by 2 is 4, and then square it. 4 squared is 16. So we add 16, but so that we're just adding 0 and not changing it, we subtract 16 as well, close our bracket, -8. And then the first 3 terms are going to form your perfect square trinomial. So they can be factored to give you the x part of the vertex. So you're going to get x, sign from the middle, square root of 16 is 4, squared, but then you have to get the -16 out of the bracket. You have to expand it out by multiplying it by a half. So -16 times a half, so times 0.5 is -8, minus 8, this -8. Or you could do -16 times 1 divided by 2, also gives you -8. So then these are like terms, so we can combine them and get -16. Don't forget your squared there. So now we have our parabola written in vertex form instead. So this tells us there's a minimum because it's positive. The a value is positive, which means it's opening upward. So it has a lowest point or a minimum. And its minimum value is -16, the k. So here's an example that's a word problem. So Curtis kicked a soccer ball. The height of the ball, h in meters, can be modeled by the formula h equals -1.2x squared plus 6x, where x is the horizontal distance, m from where he kicked the ball. Determine the maximum height the ball reached during flight. Make a sketch to help you interpret the problem. So one important thing to notice here is that when you see this, h equals -1/2 x squared plus 6x, because the highest degree on an x is 2, we know that it's a parabola. So if we're doing a sketch here, we know that this is going to be the h-axis, our y. Instead of y, they have h for height. And this is our x. And it says that this stands for height in meters, and that x is the horizontal distance in meters as well. And also, if you look at the standard form here, I'm just going to rewrite it for a second. We're going to use it anyways. But we know that in standard form, the c value is the y-intercept. And we can see there is no c value here, so it's 0. So that should mean that 0, 0, like we've touched the vertical axis or the h-axis, the y-axis right at 0 here, which makes sense if you're kicking a ball that's right on the ground, you would kick it from 0 height. And then it's going to go up and come down following a parabola. And the reason we know that is because the format of the equation has an x squared. But we want to know, what is this maximum height? So how high does it get? That's what we're trying to find out. So as soon as we see maximum and we're talking about a parabola, we know we want to put it in vertex form. So the first step is to factor the step number, which is -1.2, out of the terms containing x. So both of our terms contain x. We don't have that. The c value is 0. So negative 1.2x squared divided by negative 1.2 is just x squared. But probably not many of us know what 6 divided by negative 1.2 is, so we can do that on our calculator. 6 divided by negative 1.2 is negative 5x. Okay, so that's just factoring. All right, and now we can complete the square. So we have x squared minus 5x plus, what is it? So it may be a decimal, which is okay. So we want to do 5 divided by 2, so we take half of 5, which is 2.5, and then we square it. So 2.5 squared is 6.25. So we're going to add 6.25 to complete the square and subtract 6.25 as well, so that we're just adding 0. And then these first 3 terms are going to form our perfect square trinomial. And that's going to give us x minus, if I don't know what the square root of 6.25 is, I can do it on my calculator. 2.5. Don't forget the squared. And then that takes care of the first 3 terms. To get the negative 6.25 out of the brackets, it needs to be expanded out by multiplying it by negative 1.2. So negative 6.25 times negative 1.2 is positive 7.5. So that means our vertex is 2.5, because we have a minus here, so our h is going to be positive, and 7.5. There's our h and our k. So that means this is 2.5 meters, because you kicked, that's your horizontal distance, and then your vertical distance, your k, is 7.5 meters. Okay, that's why drawing a diagram is really helpful, because you might have trouble deciding whether the answer is 2.5 or 7.5, but when you draw a diagram, determine the maximum height the ball reached. Make a sketch to help you interpret the problem. Now we know the maximum height is the k value is a 7.5. So therefore, the maximum height is 7.5 meters. B, what was the initial height of the ball when he kicked it? So initial means start. And we can see it's 0 because we already realized that the y-intercept was 0. But what you can do is you can just substitute x equals 0 into either form of the equation. So we could put it into the standard form, or we could put it into the vertex form and we would get the same answer. Okay, I think we can see that subbing it in here, 0 squared times negative 1.2 is 0, plus 6 times 0 is going to give us 0. Maybe it's harder to see that it's going to work in here, but we're going to show that it does. So I'm going to replace x with 0, just to show that we're going to get 0 this way as well. So 0 minus negative 2.5 is negative 2.5. Make sure you use BEDMAS here, or follow how it's used on your calculator. So negative 1.2 times bracket negative 2.5 bracket squared is negative 7.5 plus 7.5 is 0. So what was the initial height of the ball? Therefore, the ball was initially on the ground, meaning its height was 0 meters. Okay, again, we could have got that easier. The calculation would be easier by substituting 0 into the standard form. How far did Curtis kick the ball? So they want to know how far this is. Okay, so some people might say, well, I think it's 5 because the halfway point is 2.5, and you're right. I just want to show you mathematically also why it is in this case. So when the ball lands, its height is 0 meters, okay? So if we have our vertex form, I'm going to bring down, so I'm bringing down our vertex form. Height equals negative 1.2 x minus 2.5 squared plus 7.5. We can replace h with 0, and it turns out that x is our only unknown that we want to solve for. Okay? And when x is only in one spot in the equation, we learned in grade 9, if we're trying to get x by itself, we can use reverse BEDMAS. So the first thing I would want to do to both sides when I'm trying to get x by itself is subtract this 7.5. So there's a 0 pair. And then I'm going to divide both sides by negative 1.2, because the negative 1.2 is multiplying the bracket where the x is. Remember, reverse BEDMAS. So you undo adding or subtracting first, then you undo multiplying or dividing. So we're following those steps. So negative 7.5 divided by negative 1.2, oops, I put 0.2. is 6.25. And then we undo exponents. So to undo an exponent of 2, we know it's square root. But this is where, with quadratics and parabolas in general, there's often 2 solutions, like there's 2 x-intercepts, okay? So we need to have this plus or minus. So if you think of way back when you first learned about square root, like the square root of 9 means what number multiplies by itself to give you 9. So there's the one that everyone thinks about, 3, and that's because 3 times 3 is 9. But the square root of 9 can also be negative 3, because negative 3 times negative 3 is positive 9. Okay, so when you're thinking about a square root of a number, by definition, two positive 3's multiply to give you the number under the square root sign, but also 2 negatives can multiply to give you the number under the square root sign. So there's often a positive and negative root that makes sense. So we have our plus or minus here. And it goes on the side with the number, okay, because we're trying to solve for x. So then we're going to see whether the square root of 6.25 is a nice number, like a perfect square number or not, without a lot of, like just an exact decimal. And it is, it's 2.5. So on the left side we have positive or negative 2.5, and on the right side we have x minus 2.5 when we undo the square root, okay? Then we undo the brackets. Well, we really had brackets around here, but once we take the square root, we don't need them anymore. And we want to get x by itself. So we're going to add 2.5 to both sides. So think about what we have here. On this side we have x. I'm just going to reverse the sides. And on this side we're going to put our 2.5 first. I know it's weird because they both end up being 2.5. And then our plus or minus 2.5 second. And then really that breaks down into 2 solutions. So we have the solution 2.5 plus 2.5, if we're thinking about the positive square root of 6.25. And we also have 2.5 minus 2.5, if we're thinking about the negative square root of 6.25. And they're both solutions. They may not be both admissible depending on the word problem, but they both are solutions to the quadratic equation. And so the 2 solutions we get are x equals 5 meters and x equals 0 meters. which actually both make sense if you think about it, because they're supposed to be how far you've kicked the ball when the height is 0. So one of our answers was x equals 0. So just before we kick the ball, it's 0 meters away from our starting point. And our other answer was x equals 5 meters, which is how far we kicked the ball. So the next time the ball lands on the ground, it's 5 meters from where it started. So they both make sense, but because the question asks how far Curtis kicked the ball, the answer is therefore Curtis kicked the ball 5 meters. Okay, the next example. An auto parts manufacturer models their monthly profit with this quadratic relation. So it says it's quadratic, but also as soon as you see that x squared, we know it's a parabola. Where P is profit in thousands of dollars. So that thousands of dollars is important. And X is the number of parts produced also in thousands. How many parts should be made in order to maximize profits? So when you see maximize or minimize, you know you want to change it from standard form into vertex form. Draw a sketch of this relation. Label it with significant points. So I'm going to draw, because I see that my y-intercept is negative, I'm going to kind of draw my drawing like this. Instead of y, I have P profit, which is in thousands of dollars. I'll just write dollars, but I'm remembering thousands of dollars. And then X is the number of parts in thousands. And we know that my y-intercept is down here at negative 198, so I'm going to keep that in mind, okay? Or my p-intercept. How many parts should be made in order to maximize profits? So I'm going to start off with my standard form. And I'm going to factor the -6, the step number, out of the terms containing x. So if I do that, I'm going to get x squared, and then I'm going to do positive 84 divided by -6, which gives me negative 14x. And then close my bracket, minus 198. So I'm putting it in vertex form, so I know where my vertex is, okay? I'm assuming there's a negative step number, so I'm going to go up and then down, something like that, okay? And I want to know what my maximum profit is and also how many parts, because that question asks how many parts I should make to get my maximum profit. So I'm putting it in vertex form, so I'm going to do x squared minus 14x and then complete the square. So I'm going to take half of 14, which is 7, and square it, which is 49. So add 49, subtract 49, close my bracket, minus 198. So these first three terms inside the bracket form the x part of the vertex. So it's going to be x, sign from the middle is negative, square root of 49 is 7 squared. And then to get the negative 49 out of the brackets, I have to multiply. Negative 49 times -6 is positive 294. But I still have the minus 198. And they go together to give me the k for my vertex. So minus 198, 96, plus 96. So that vertex is 796. So this is 7, but it's really, we'll talk about that in a second. This is 7, and then this is 96. But remember, these are in thousands. And remember that this question asks how many parts should be made in order to maximize the profit. So if I'm looking at my picture here, the maximum profit is $96,000 because it's in thousands. But that's not what they're asking me. They're asking me how many parts I should make. So when there's a $96,000 profit, it means I had to make not 7, but 7,000 parts because it's number of parts in thousands. X is a number of parts in thousands. So another reason to draw the graph is, again, to interpret your vertex, okay, and see what answer the question being asked. So it didn't ask what the maximum profit is, even though I found the maximum profit by completing the square. But it's asking me more to interpret this part of my vertex, the 7, which means, therefore, 7,000 parts should be produced to maximize profit. We know that the maximum profit is $96,000, but it doesn't ask us for it. Okay, so be careful that you answer the question they ask. Okay, part B, for what number of parts produced does the manufacturer make a profit of $58,500? And then why is there 2 answers again? So there's going to be 2 answers similar to the last question. We can see that this is $96,000. So say 58 was about here, 58,500, so 58.5. We can see then that there'd be 2 numbers of parts, one more than 7,000 and one less than 7,000, that would lead to a profit of 58,500. And often people think about why is that, and that troubles them. Because it follows a parabola, that's why it is mathematically. If you want to think of realistic reasons, maybe they have to hire more workers and then they don't sell as many, so their profits aren't quite as high while they have to pay more people, okay? You can think up reasons why they shouldn't just make as many as possible, supply and demand, okay? But really, we're just thinking about this parabola here and the fact that if we make $58,500 in profit, there's 2 ways you can do that. One by making less than 7,000 parts and one by making more than 7,000 parts. And we want to find what those 2 numbers of parts are. So basically they're giving me a P, and I'm going to say it's 58.5 because it's in thousands. Okay, they're giving me 58,500 or 58.5 for profit. And they're asking me what values of X go with that. So it's similar. I'm going to use the vertex form because that's got X in only one spot. So it's easier to use reverse BEDMAS than if X is in 2 spots, which we can't do. And so in the next few days, we're going to learn other ways to solve a quadratic, but reverse BEDMAS is a good way, especially if we've gone to all the trouble of already putting it in vertex form and getting the X only in one position, rather than being in 2 positions, how it is in standard form. Okay, so now we've got a number everywhere but here, so we can use reverse BEDMAS to slowly get this X by itself. So we're going to subtract 96 on both sides. So we're going to do 58.5 divided by, or not divided by, 58.5 minus 96, negative 37.5. And then divide both sides by negative 6, which gives us 6.25 again. Square root both sides. Again, maybe we'll see the importance of the plus or minus a little more in this question than we did in the last one. But we need it, okay, because there's a positive square root and a negative square root, or a positive square root and a negative square root. That makes sense. So to get 6.25, you can either do 2.5 times 2.5 or negative 2.5 times negative 2.5. So they're both considered square roots of 6.25. Then we want to get X by itself by adding 7 to both sides. And then I'm just going to switch it around so the x is first. We've got, I always like to put my integer first, so 7, and then plus or minus the 2.5. I'm going to erase this. I could have also had the plus or minus 2.5 plus 7, but I find that harder to work with when I'm trying to figure out what my two solutions are. So then we're going to come up here. I'm just going to recopy this. And this is where we are going to go from writing it in this plus minus form into our two solutions. So one of our solutions is 7 plus 2.5, and one of our solutions is 7 minus 2.5. So that's going to be 9.5, and that's going to be 4.5. Okay, now what does that mean? That means if we looked at our picture here, this would be 4.5, the one that's less than 7, and this would be 9.5, the one that's greater than 7. And what does it mean? It means to earn $58,500 in profit, either, so these are in thousands, remember, 9,500 or 4,500 parts should be produced or would be produced. Okay, so remember that these are in thousands as well. Why is there two answers? There are two answers because the square root of 6.25 can be 2.5, or the square root of 6.25 can be negative 2.5. Oops. There are two answers because the square root of 6.25 could be 2.5. It could also be negative 2.5. Also, if you just think about quadratic equations, so when their degree is 2, can have two solutions. So in grade 9, we always talked about linear equations, so we didn't have an x squared, we just had x, and there was only one solution. In grade 10, equations that have an x squared in them can have up to two solutions. Okay? And graphically, we can see why it makes sense for it to have two solutions. All right, and our last example. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by the function h equals negative 16t squared plus 64t plus 80, where h is the height in seconds and t is the time in seconds. What is the height of the rocket after 1.5 seconds? So this question here is just, all it's asking you is what's height when time is 1.5 seconds. So I don't need to put it into vertex form to do that. I can just use the standard form and substitute 1.5 in. And then I can just input that into my calculator. So negative 16 times 1.5 squared plus 64 times 1.5 plus 80. So we get 140. Height is measured in feet. So what is the height of the rocket after 1.5 seconds? Therefore, the rocket is 140 feet above the ground. What is the maximum height? So, okay, as soon as we see maximum height reached by the rocket, include a sketch of the situation with important parts labeled. So we can see that the y-intercept is 80, so I don't have to make a negatives this time. So this is my height, and T is my time. And I'm going to start at 80 feet above the ground. So it's launched from a hill, 80 feet above a lake, actually. And the rocket will fall into the lake. So it's parabolic with a negative step number. So it's going to go up into the air and then come down and hit the water. Okay, and we know this is 80. We know our height's measured in feet. And our time is measured in seconds. So this is 0, at 0 seconds, we're 80 feet above the ground. And then we want to find out at what time they get to their highest and what the height is, the maximum height is. So we can label those important parts on our graph and answer the question, what is the maximum height? So we start off with the standard form, and then we use completing the square to put it into vertex form. So we're going to factor the step number out of the terms containing t, close brackets, plus 80. And then we're going to complete the square, so minus 4t. We're going to take half of 4, which is 2, and square it, which is also 4, so plus 4 minus 4, so we've just added 0, plus 80. T minus 2 squared. Get the negative 4 out of the bracket by multiplying by negative 16. So 8, that's plus 144. So that means our maximum height is 144 feet and at 2 seconds. Okay, our vertex is 144. So what is the maximum height? So therefore, the maximum height is 144 feet. After how many seconds after it's launched will the rocket hit the lake? So in other words, when is height 0? When it hits the lake, its height above the lake will be 0. So we're going to take our vertex form. And how many seconds is they want to know the time? When h is 0. So we can use reverse BEDMAS after we've replaced 0, h was 0, to get t by itself. 0 pair. $144 divided by 16, they're both negative, so I know it's going to be a positive, is 9. Square root plus minus, so positive or negative 3, because the square root of 9 is 3, is equal to t minus 2. Add 2 to both sides. So we've got t equals 2, we're going to put the 2 first, plus or minus 3. So we get t is 2 plus 3, and t is 2 minus 3. So 5 seconds or negative 1 second. So this is an example where we get two mathematical solutions. So the 5 seconds is obviously our answer. The negative 1, like if we work backwards with our parabola, negative 1 is here, but we call this solution inadmissible for this question because it doesn't make sense to have negative time. Okay, so this is a mathematical solution, but it's inadmissible for our word problem. It doesn't make sense to have negative time. So we know that the 5 is the answer that we're looking for here. So therefore, after 5 seconds, the rocket hits the lake. Okay, so that inadmissible is an important one. Sometimes when you get a positive and a negative solution, the negative won't make sense for a real life word problem. So always think about your solutions when you're answering the question. All right.